Assalamualaikum warahmatullahi wabarakatuh and good day to each and everyone. So this is E223 and this is Sir Hanif. So last meeting we have already discussed our we have discussed some of our topics which is vector calculus. Okay, so right now we will be going through Fourier analysis. Okay, so this is the very important. This is one of the very important topics that we have to deal, no? Because um, we can actually apply this one in our major subjects. Okay, so um, this is very important at all actually. Okay, so we have here a Fourier analysis. Okay, so what do you mean by Fourier analysis, or what probably can we gain from this topic? So Fourier series are infinite series that represent periodic functions in terms of cosine and sines. So since in our major subject, we are probably dealing with the sine and cosine functions, okay, most probably. So therefore, we have now this one. We have to. This is very important for us, in short. Okay. So in here, um, we have here an infinite series that represent terms of cosine and sines. Okay, then a function f of x is called periodic function if defined for all real x, except possibly at some points, and if there is some positive numbers p called period of f of x such that if we take that or if you use that period, so f of x plus p is just equals to f of x. So it means that um, the function or the sine function or cosine function are um, periodic itself. No? So we have here an example. No? So if we see this graph here or series of values here, no, after this period p, the value of this wave is repeating. Okay, so that's why we call this one as a sinusoidal. Okay, or no, we call this one as a periodic function. Okay, and this is not a sinusoidal, no. This is just a periodic function, and the sinusoidal or cosinusoidal na function is a periodic function. But these are just some example of periodic function. Okay, so this is the so in short, no, this function can be represented as a Fourier series, no, since it is a periodic function. So in short, for us to be able to apply a Fourier analysis, a Fourier series, no, to take the representation of that function into a Fourier series. Okay, so um, we first make sure that that function is a periodic function. Okay, so this is the test or equations that we should uh, satisfy satisfies in order for us to conclude that the function that we are dealing is also a periodic function. Okay, so these are just some of example of periodic function, no? So one, no, is a periodic function. Cosine x, sine of x are all periodic function. Cosine of 2x, sine of 2x or is also a periodic function, and same for cosine of nx, sine of nx, and so on and so forth. Okay, so for the sine and cosine, most probably their period is 2 pi, no? 2 pi is yan yung mga period natin. So we know that already from our previous trigonometry, no? So these are just some of the trigonometry system that we are dealing with, no? So um, for this, no, we can see that they are all sinusoidal. Okay, they are all sinusoidal. So the series to obtain will be trigonometric series. That is series of the form a sub o, a1 cosine of x, b1 sine of x, a2 cosine of 2x, b2 sine of 2x. So these are just some of the series that we can get for us to be able to represent a certain function or a certain periodic function into a Fourier series na representation. Okay, so we have now this one. Okay. Uh, where a sub o is called as a fundamental component or fundamental uh, or the average value of the kuan of the tawag dito, function. And for the en, that is the even function, and for the bn, that is the odd. Okay, if I'm mistaken. These are the coefficient pala, no? Okay, so we can get this one by using Euler formula. Okay. So now we have here an example, no? So find the Fourier coefficient of periodic function f of x and figure 260. The formula is this one actually, no? So ibig sabihin nito is that yung f of x daw natin is equal siya sa negative k if yung x natin is in between negative pi to 0 and it is equal to positive k if yung x natin is in between 0 to pi. Okay? So this means that f of x plus 2 pi is equals to f of x. This means that meron tayong period na 2 pi, no? So if you remember, no, yung test natin for identifying that the function is period is this one, no? So yung yung p natin dito for this function dito sa example natin is equals to 2 pi. So this means that we can say that this is actually a periodic function, okay? That has a period of 2 pi. Okay? So by using these equations here, ito yun siya, itong coefficients dito. Okay, so we can now find this an, bn, and yung a sub o. Okay, so then after that, we have now this the representation. Okay, so we have this simplification. These are just the coefficient, b1, coefficient of the bn, so b1, b2, b3, bn, b4, b5, so and so forth. Okay, so we have now here the final representation of Fourier series. Okay, so um, uh, what do you mean by this series of um, manipulation of this f of x, no? So it means that okay, originally um, after the series of uh, after the summation of after the summation or sum of all the particular sinusoidal graph here or function here, after we sum up them, it will sum up to this sinusoidal na term, no? So it means that in using Fourier analysis, in using Fourier analysis, what we do is we are summing up all the possible components of the sinusoidal function, and by summing up that as a whole, we can get the original na tawag dito, original na graph, no? So that summation of all the sine and cosine terms are represented by Fourier coefficient, no? Ito yun siya, itong bn, en, and a sub o natin. Okay, so that are the tawag dito, coefficient of the Fourier series, no? So yun yung ibig sabihin ng Fourier series natin actually. Okay, so now let's go on to arbitrary period, no? So in this method, we can actually find out, okay, or we can get or we can assure a certain properties of a Fourier series, no? So we will be using those period of sinusoidal na function to simplify the manipulation of that. Okay, so we have this one here. And hindi ko na to babasahin. These are just an orientation or basic information regarding on how to simplify the manipulation or simplification of the Fourier analysis into a simpler one by using the period of sinusoidal and cosinusoidal na function. Since in this Fourier analysis, we are mostly dealing with the sinusoidal and cosinusoidal na function. Okay? So we will go through on this one. So by comparing this equation here doon sa equations natin dito na ginamit natin dito sa examples, dito yun siya, we can notice that for the ang nag-iba rito is yung ating constant dito or yung coefficient dito. Doon, okay, is we are using 2 pi, no? We are using 2 pi, di ba? 2 pi, pi, and pi. Dito, we use L, no? Why? It's because here, these are the general case, no? We can use this one for all functions as long as they have a period of L, no? Period of L. So in this case, instead of assuming that um, we are just dealing with the sinusoidal na function, we make it general to analyze all possible function, okay, or that has a period of 2L. Okay, so that's why we use this equation here. Okay, so once again, yung tatlong equation natin sa taas na pinakita ko, yun is para lang yun siya sa sinusoidal, okay, na function. Ito, okay, that has a period of 2 pi. Dito sa baba, this is for general case, no? So we can apply this one for all possible forms of function, okay, 2L that has a period of 2L. Okay? So anyway, meron naman tayong kuan dito, no? Example. So periodic rectangular wave, no? So ito yung siya, ito yung itsura ng periodic rectangular wave. So represented by this equation. So sabi dito, yung function daw natin is equal siya sa 0 when our x is in between negative 2 to negative 1. So ito yun siya, no? From negative 2 to negative 1, equal siya sa 0. Okay? Then it is also equal to k if our x is from negative 1 to 1. So from negative 1 to 1, saan tayo? From negative 1 to 1, so yun, equal siya sa k. And 0 na naman pag 1 to 2. Okay? So 1 to 2, so 0 na naman siya. 1 to 2, and so on and so forth, no? So on and so forth. So yan pala, yan yung nauulit. So as you can see here, this function is a periodic that has a period of 2L, no, which is equals to 4, no? If you take a look on the repetition of these values, so it will repeat on a certain value of x, okay, which is equals to 4. So therefore, we can now know that L is equals to 2 by dividing the this equation both side by 2. So we have this L is equals to 2. Okay? Now, substitute the value. Okay, substitute natin dito. Okay? So, mangyari is that, yung a sub n natin is equals to 0, no? Since, if we use this one, that will be equals to 0, and en now, and is equals to this one. Okay? So, we have now this the final answer of Fourier series. Okay? Now, so we have also here an example, so take a look on that one. Okay? So, please. Okay. So now dito tayo sa another topic which is the simplification of even and odd function. So kung itong part na to rito is to simplify or to have a general case, no, in order to apply a Fourier analysis with any forms of function, dito naman sa section na to sa baba is we simplify the form of the function. Okay? So it means that if that function is even function, okay, we can use this equation, no? We can use this equation if that add, so we can also simplify the representation. So these are summarized in this box here. So we say here that for even function, okay, of period 2 pi, we only use a sub o, coefficient a sub 1, a sub n. And for the add function of period 2 pi, we only use dn, coefficient, no? Okay, pero for the formula, ganun pa rin yung formula natin dito. Okay? yung ginamit natin dito na formula for general case ito. Okay? So once again, ang pinagkaiba nga lang doon sa section 3 kay for the function that is not even, so we only use this one a sub 1 a sub n. For the add naman, we only use this b sub n. Okay? So okay, so we have now this one. So we have here the representation of half range expansion, and we have also here the an example. So please read that one as all. So once again, these are just an simplification on how to deal with the Fourier analysis, no? Okay. So once again, no, what do you mean by even function pala? You can know that the function is even the value if the value of the uh, if the value of the function, okay, if the value of the function is um, projected to the other side, no, so that is an even function. So ibig sabihin uh, kung i-mirror natin to siya or okay, kung titingnan natin yung relationship sa dalawang kabilang side, so they will form a mirror, no? Sa add naman, sa add na function natin, okay, yung sa side natin sa positive x, okay, it's opposite of the other side, no? So you can see here that this graph here is on this other side for the negative x-axis, no? So yun. So that's all for this discussion, I think. So we have a lot of example here, no? And quizzes. So kindly answer this one. So if you have any question regarding this one, kindly ask it to me right away. Okay? Para wala tayong problema. So I think that's all. Good day. Assalamualaikum warahmatullahi wabarakatuh.